I've been working on a car for quite some time, and I have found that one of the windshield wiper switches is unable to work on my car and is no longer under manufacture. So I had to remove the switch completely and then rebuild the switch, making sure the plastic was in good shape and also cleaning contacts, re-riveting everything back together. Once I was complete, I needed to make sure that all of the contacts were complete, that they were in good shape, and that they functioned appropriately. Because I had my voltmeter, my wonderful little device to make sure all the contacts were working when they were switched, was out of battery and I needed something quickly, I actually turned to an Arduino to make that happen. This is how my Arduino has been set up. Just quickly, what I did use is I used the basic button digital sketch. When the button is pushed, pin 13, the LED turns on. I took that and I modified that a bit because on my connector there are actually 4 connectors and I needed 3 lights to be able to show me the states of all 3. Just as a quick demonstration, we'll go through, we will enable the switch, you can see the lights turn on, and I will also demonstrate the use of the serial so that I could see the states currently on the fly. I have a 100 millisecond delay. That gave me close to real time. I didn't need fully real time on this one. I didn't need to see instantly when things would go. So I was able to just go with 100 milliseconds. It was quick. It allowed me to see what I needed to see. And it looks like the switch is working pretty good. So here we go. Here's a quick demonstration of this. First, just a quick demonstration of the sketch as it's going, the serial port, the communication, what it's writing. Over here on the laptop, I have right here the output as it goes, constantly feeding. This output is showing me each of the states, and as I were to flip the switch, you would be able to see those states change. I didn't use the serial port initially because I was just trying to use the LEDs, but I needed this because I had something improper in the sketch. Got that corrected, and then the rest of the sketch was able to work just fine. So here's my switch. The switch is right here. And this is what I had to rebuild. This is no longer manufactured, no longer created, and I needed to make sure when the shaft was turned, the lever was turned, that the proper contacts on this side were connected. I found that some of the wires had been cut in this area, and so I actually had to clean things off. I actually had to drill the rivets on each of these sides to make sure I could get these out. The back side was covered in paint, and so the contacts were failing to work on that one. So the first thing that I had to do, I had to drill the rivets, I had to get the contacts off, clean the contacts, make sure these were okay. I then used a rasp on the inside to make sure that these contacts were functioning okay, that they were clean. Once that was done, I was able to hook up the other end of my connector. I actually drove in 3 rods and put alligator clips on them, ran the alligator clips over to my Arduino. I have 3 LEDs. I know there are 4 contacts, but I needed 3. One of those contacts was actually a common. That's been tied to a ground. The other 3 have been tied to the contacts, so that when I flip the switch, we should be able to see some sort of activity on these, and which is actually very true. The way I coded it, the lights turn on when nothing is connected. I did this because I just wanted this to remain as simple as possible, so I utilized the pull-up resistor that was inside on each of those inputs. I had them pulled up, which means when nothing is connected, they go high. Because I tied ground to all 3, that when the switch is connected, it grounds it out and then promptly turns off the LED. So by default, the LED is going to be on. Once I establish the contact, it will turn off. Hence, it looks kind of backwards on this, but it functions. So just as a demonstration, this one right here is when I push the shaft in, the lever in order to activate the spray, the washer spray. And then these two over here are going to be on either in variation mode or off or in full speed on the switch. Because this is for a 1977 vehicle, there were only the 3 modes on there, so there wasn't a nice variable that you would see with the current with the modern windshield wiper switches. So pushing it in, that other light should go off. Pulling it back out or releasing, that light should come back on, which means that switch that I had riveted these two on is functioning just fine. When I rotate, in the off mode, 1 pin goes high, 1 pin goes low. When I switch it to the middle or the variation, they both turn off, which means they're both grounded out. And when I go into high mode, the other one turns on. So I can make the switch back and forth, and each one of those will go on fairly quickly. Apologies for that. I hit the wrong button on this little thing. All this technology makes me a little bit nervous, but we're able to get that back. So just a quick zoom here so you can see these things working properly. 3 LEDs, and then we'll go through the switches. First, the windshield, the spray, the water pump, turning that, should do that. Releasing, that one turns on. I should then be able to start working through and making sure each of these states works just fine. And it does indeed look like everything is good. Just to make sure we have everything in the right spot on my connector, I have the different colors of wire going in, and the next thing I need to make sure is that these switches line up just right. You will see right here on my wiring schematic, I actually have a list of these connectors, the colors, what they represent, and when they are connected. And that is indeed what we've got. So, congratulations, I've been able to rebuild a switch, and I'm happy I don't have to go hunting for a used one that's in fairly good shape, because now I have one that's working. Thank you.